Hi, I'm Bill Sroor from Dev Mastery, and welcome to another episode of Mastery Monday. We are live on Monday night, and I'm pretty excited to share with you today a few tips around refactoring. So if you don't know, refactoring is when you take your code and you change the implementation without changing the behavior. And the idea behind it is you're trying to improve your code bit by bit, so you're making changes that hopefully make the code a little better. And in the past few years, I've really sort of taken to some of the ideas behind functional programming. And in particular, one of the ways that I tend to refactor my code these days is I turn it into smaller functions that I can pipe together. It's something called pipeline style programming. So I take a bigger function and I break it down into smaller functions, and then I compose those functions together using something called pipeline style programming. Don't worry if you don't know what that is or how that works, or if the idea of functional programming is still new to you. This is not like going to be an intensive functional programming overview. I'm just going to show you one technique that I've been using with some success in the hopes that you'll find it useful and you'll be able to deploy it in your own code as well. So why don't I stop just talking and start coding. So let me show you a little bit of code. I should warn you, by the way, the code I'm going to show you is pretty contrived. It's sort of a silly little example, and that's it's done that way just because to show you more realistic code, the code would be really big. There'd be a lot of context to grasp, and it might be complicated. So I chose a bit of a silly example, but even though the example is silly, the technique is less silly and probably something that you're going to find, hopefully you're going to find quite valuable. All right, let's see if we can get into some code. So here we go. Hopefully you are seeing some code right now. So I have this this function called reverse sentence, such that you could do something like this. So you could call reverse sentence with a string like yawadna poo poo, right? Yawadna poo poo. And so yawadna poo poo becomes, you can see over here, yawadna poo poo is going to become up, up, and away. And you can see a couple of things happening here. So obviously the string is being reversed, and then we're uppercasing the first character, and we're adding a period at the end. And like I said, this is a trivial bit of code, but it's just for the sake of this example. So you know, imagine this is something more real. So if we look at the implementation of this reverse sentence, you can see there are a couple of different steps. So the first step is we reverse the string, and the second step is over here we uppercase the first character of the string, and then the last step is if there isn't already a period, we add a period to the end. Okay. And so, I mean, I can't imagine why someone would write this particular function, but I can definitely imagine, and certainly I've done it many times, you know, a function where you take some sort of input and then you process it in a number of steps. So you do a variety of things to one piece of input. Okay. And so for the sake of this example, just imagine that what we're doing here is a little bit more complicated than just, you know, reversing, uppercasing, and adding a period. So if this was the real code, like this is all it was, I probably wouldn't bother refactoring it at all. I wouldn't touch it. It's fine. I mean, these are one-liners. They're not worth extracting. But if you imagine that these steps, so the reversal of the string, the uppercasing of the first character, and the adding of the period, if you imagine those to be something a lot more complicated with a lot more code involved, you could see that you would want to perhaps break those down into smaller functions. So with that in mind, let's do that and see where we can get to. So we'll start by extracting this string reversal. So we can create a function called reverse, and that's just going to take a string, and it's going to return the string in reverse. So it'll look something like this. And now we can sub in here reverse string. right? And so everything still works. So you notice the implementation is starting to change, right? But the behavior has not changed. So it's the same behavior, and we've started to change the implementation. And for the sake of saving space and making this a little more terse, I think I'm gonna switch to arrow style functions. So we can go const reverse equals, and we'll take in a string and pass in an arrow function. So we don't need this. Okay. And let's clean that up a little bit. So maybe something like this. And so we see we're on our merry way refactoring. So now we've got this little reverse function here. Oh, and we can not string, right? So we're on our merry way. We're refactoring here. So we've got this reverse function. Let's extract this business here that uppercases the first character. So we'll use an arrow function as well. So we can go const upper first equals, and then we'll again take in a string, and we'll have to return this. And of course, instead of reversed, this will be the original string. So that looks something like that. And so here, by the way, this upper first, we're just grabbing the first character from the string, setting it to uppercase, and then concatenating it with the rest of the string. So starting at position 1 and doing the rest of the string. And so now we can replace all of this with upper first string. Nope, upper first reversed. There we go. Okay, so now we've got, again, the behavior is the same, but we've started to refactor. So we've started to change the implementation by extracting smaller functions. And I guess the last thing we can do is we can do this add period function. So add period equals, and that'll again take a string, and it will return the string plus this little ternary expression here. So let's do this. So something along these lines, and of course this is string. Okay, and so now we can replace this bit of business with add period reversed. And actually what we really want is we want to put this inside here, and we can remove that. There we go. And actually we can, while we're at it, we can also inline this, right? So we can grab that, put it in here. Okay. And so now what we're starting to see emerge is that this reverse sentence function is really becoming a composition of these three functions. And so if we rewrite this in the arrow syntax, so const reverse sentence, we'll string, okay. So you can see now this reverse sentence function actually is just a composition of other functions. So there's nothing that's going on inside of reverse sentence. It's just composing together a number of other functions. So when you have something like this, it would be nice to be able to have some utility function that can do this kind of work for us. So that can take the situation where you're just composing together a number of functions and can just take the functions you want to compose and compose them for you. Because when you're looking at code like this, it can be a little bit tricky to read. It can get confusing, especially if there's multiple. So we've only got 3 levels here, but you can imagine 4, 5, 6 levels. It gets pretty hairy. So there's a library called Ramda that has a lot of very, very useful functions. And one of those functions is something called compose. So if we import Ramda in here, what we can do is we can call r.compose and pass in our 3 functions. Like that. So now we've got this reverse sentence, which is just a composition of these 3 functions. And this style here, this is something called point-free style. So we don't even have to specify the parameter. This is just a function that's going to return a function. And so that works well. But to me, these now are kind of backwards. So the last function here in the list is actually being applied first. So I would rather see this the other way around, so that the first function in the list is applied first, then the next, then the next. And so that's where this idea of pipeline style programming or piping comes in. So Ramda also gives us a function called pipe. So we can say, instead of compose, we can say pipe, and then we can put these in an order that, for me at least, and it's going to depend on your own preference, but for me, this order makes a little bit more sense. And so now we're piping, so we're taking an input and we're piping it through a series of functions. So we're getting one input, we're piping it through a series of functions. And this is a super useful way of thinking about your code. So if you can build a code base based on tiny independent functions that obviously work, and then build sort of higher level functions that all they are is a pipeline that passes the data through these tiny independent functions, you can get a nice readable, reusable, testable, understandable set of code. One mistake that I see a lot when people try to refactor, they take a function and then they try to break it down into smaller functions, is instead of making each function independent, what they do is they have one small function called the next small function called the next small function. And I don't recommend that you do that, because what happens when you do that is basically you create a sort of a chain of dependency, and you also, it can be difficult after to go back into the code and understand what's going on in terms of, you have to dig down multiple levels before you fully grasp what exactly is happening in the code. And so when you do it this way, where you have each function is independent, then you can pipe them together. So you have one kind of higher level function that pipes together the smaller functions. Then you don't have to dig as deep into the code base to understand what's going on, because things are just one level deep. And of course, as always, naming is super important. So if you've named things, if you've given things good names, and it's hard, but if you've given things good names, it starts to become really obvious and apparent what your code is doing. So I'm frequently looking for opportunities to do this, where I'm building one larger function that's just a composition of lots of little independent reusable functions. Now, like I said originally, this is a trivial example, and the code that we had at the beginning was not really complicated enough to warrant this kind of refactor, but you have to give yourself, or imagine for yourself, that this was actually, these steps were a lot more complicated. And so if you were dealing with more complicated steps, then it's very worthwhile doing this. Now, a couple things to add and to note here that are probably going to be useful and interesting for you. So one is, you'll notice these are just regular synchronous functions, but a lot of times we're dealing with functions that are promises, especially in JavaScript. So we're working with asynchronous code. So if we were to make this function, for example, async, we would get back now a promise, and then console.log. And so it breaks, right? Because pipe is expecting synchronous code, but there is a Ramda function called pipe_p that will expect promises. Now, the only thing with pipe_p is the first function that you pass to it has to be a promise. So the other thing that I should touch upon is this works really well when your functions are unary. So the second and third and fourth, fifth, whatever function in the chain has to be unary. That means it takes only one parameter. And so that might feel a little bit limiting at first, but if you are writing your functions in a style where they receive an object, so the parameter that it receives is a single object and returns an object, then you can really take advantage of this piping style. So by receiving an object, it's just one parameter, but then you can destructure the object, and so you can take in larger input as long as you're passing it along, right? And so the other thing I'll say too is if you need to have a pipe function that works for both synchronous and asynchronous code, and you don't want to think about it and just be able to mix the two, I've actually built my own sort of version of a pipe function that I shared on Twitter a while ago, and it's actually a pretty easy function to write. So I'll show it to you. So here's my sort of implementation of a pipe function. And so this just takes in a list of functions and returns a function that will loop through all the functions you passed in. And if the function happens to be a promise, it will execute it using a thenable. If it's not thenable, then it will just execute the static function. And so we can replace the Ramda implementation with my own. Okay, and it still works. It works the same way. And now it doesn't matter whether it's, whoa. What did I break? Oh, yeah, so it would work without, it's just because I'm calling then here. So if I remove the then and then make none of these async, so it works fine with synchronous code. If you have async code, then obviously what it's going to do is it's going to return you a promise. So you need to use a then to read the result. Okay, and so I'll put a link in the description to this function. In the meantime, couple of things I'll show you. So Ramda is a super useful, super interesting library. One of the things is, well, what it is it's just a set of utility functions, but it's built around functional programming. So if we take a look at a website, which I'll share in the description later, there's this website called, it's a blog called Courageous Software, and they have a beautiful article called Thinking in Ramda. And what this article is about the Ramda library, but it's also about functional programming. It's a very nice, gentle introduction to some of the concepts of functional programming. So I'll put this in the description as well. And then, of course, you can just, search for Ramda.js, and you'll come upon all these websites as well. So this is their official homepage for the Ramda library. And again, it's just a library of utility functions in JavaScript, but they are super useful. And then the last thing that I'll tell you about, and then I'll go and look at some questions, is there is a proposal right now, very early stages, to add what's called a pipeline operator to the JavaScript language itself. So a lot of functional programming languages like F# and Elm, Elixir, Hack, they have this operator, which looks like it's a little pipe, and it's a pipe and an arrow, or a pipe and a greater than symbol, and it allows you to do this kind of pipeline style programming. So they have on this proposal page, which I'll also put this in the description, they have sort of an equally trivial example. So they have a function that double say, which takes a string and repeats it twice, a capitalized function, and an exclaim. And they show you here how you can use this new proposed pipeline operator to run these functions in a pipeline. So you've got your input, and then you pipe it through your various functions. And so this is super interesting. It is very early stage, but it might find its way into the JavaScript language itself. So if you become accustomed to writing your code and refactoring your code in this way, then you'll be in a position potentially to really take advantage of this when it comes into the language. And like I said, it's super useful in general. Okay, so I'll see if there are any questions, and I'll take questions. So let's see if I can. Okay. So yeah, does Ramda only just provide a bunch? Yeah, so that's what Ramda is. It's just a library of utility functions that is put out there. It's similar to Lodash, if you've used that, or underscore if you've used that. So lots of really useful utility functions. It's something that is worth exploring. And a lot of times I find myself either depending on the size of the project and how many of those utility functions I'm using, I'll either bring in the library, or if it's just one or two small, if I've got a tiny project and it's one or two small things that I'm using, I'll just sort of make my own version and draw inspiration from Ramda. So I don't know if there are any more questions. If not, just a reminder that I am here every Monday night at 10 p.m. Eastern Standard Time, live on YouTube. I'm just sharing, small tips, advice about, how to improve your code, and eventually we'll talk about some career stuff too, I think. So just looking for ways for making our code better, and sharing some stuff live, coding live, casual. Please, if you haven't already, subscribe to the channel. Come check me out next Monday at 10 p.m. There's also I just saw another question here from someone. They're asking if I suggest implementing pipeline technique in Python also. Yes, I actually suggest this pipeline style of programming in almost any language where you have functions are first-class citizens. So where you can pass in a function as a value, I recommend exploring this this technique of doing pipeline style programming. It's very useful. At least I've found it very useful. Now, having said that, there's a tendency, I know, when you learn a new technique, to go back to your code or to write all of your code in this way from this way forward. You really have to, you don't just use it blindly. Think about, in this particular situation, would a pipeline style actually make this code easier to understand and better? So if it's an actual improvement, then yeah, use it. So in any language where you have functions as first-class citizens, where you can pass them around. Okay. All right. So that's great. I think I'm going to end it there. Listen, if you're watching this on the replay, if this is the first time you've watched me, I highly recommend you subscribe, turn on the notification bell, and I'd love to hear your thoughts in the comments. If you liked it, thumbs up. If you didn't like it, thumbs down. But please let me know what I could do better, because really my goal is just to help as many people as possible. So I'm here every Monday night. Thanks so much for joining me, and I'll